NASA has released the Matrices and Annual Scaling Index of Antarctic Ozone Hole. As the news getting from NASA has said, persistent cold temperatures and strong circumpolar winds, also known as the polar vortex, supported the formation of a large and deep Antarctic ozone hole that should persist into November, NOAA and NASA scientists reported today. The annual Antarctic ozone hole reached its peak size at about 9.6 million square miles, 24.8 million square kilometers, roughly 3 times the area of the continental United States, on September 20. Observations revealed the nearly complete elimination of ozone in a 4-mile-high column of the stratosphere over the South Pole. Ozone consists of 3 chemical element atoms and is very reactive with different chemicals. Within the stratosphere, roughly 7 to 25 miles on top of Earth's surface, the ozonosphere acts like sunscreen, shielding the world from UV that may cause carcinoma and cataracts, suppress immune systems and injury plants and sensitive being at the bottom of the world food chain. By contrast, the gas that forms nearer to Earth's surface through chemical reactions between the sun and pollution from vehicle emissions and other sources forms harmful air pollution in the lower atmosphere. The Antarctic hole forms throughout the southern hemisphere's late winter because the returning sun's rays begin gas-depleting reactions. Cold winter temperatures continue into the spring, alter the ozone depletion process. That is why the hole types over Antarctica. These reactions involve chemical active types of gas and atomic number 35 derived from semi-synthetic compounds. The chemistry that ends up in their formation involves chemical reactions that occur on the surfaces of cloud particles that form in cold stratospheric layers, leading ultimately to runaway reactions that destroy ozone molecules. In hotter temperatures, fewer polar stratospheric clouds form and that they don't persist as long, limiting the ozone depletion process. NASA and the agency use 3 complementary instrumental methods to watch the expansion and breakup of the hole every year. Satellite instruments like the Ozone Monitoring Instrument provided by Holland and Suomi on NASA's AURA satellite and the Ozone Mapping Profiler suites on the NASA NOAA Suomi National Polar Orbiting Partnership satellite and the NOAA 20 Polar Satellite live gas across massive areas from space. The AURA satellite's microwave limb sounder also measures each ozone and bound gas-containing gases, providing estimates of total chlorine levels within the stratosphere. NOAA scientists monitor the thickness of the ozonosphere and also the quantity of ozone depletion, how very little is left inside of the hole. They frequently unharness weather balloons carrying ozone measuring sondes on top of the South Pole that ascends up to 21 miles in altitude, and, once sunshine returns to the Antarctic when the long polar night, with a ground-based instrument referred to as a Dobson spectrophotometer. This year on October 1, gas measurements taken by instruments carried aloft by weather balloons from NOAA's Pole Region Observatory recorded a coffee price of 104 Dobson units. NASA's GasWatch reported rock bottom daily value for 2020 from satellite measurements was 94 Dobson units on October 6 over Antarctica. Brian Johnson, an individual with NOAA's World Observance Lab, same scientists specialize in the layer between 8 and 13 miles in altitude, that is wherever major depletion occurs. In late October, gas levels within the key altitude vary remained getting ready to record lows. It's concerning as close to zero as we are able to measure, Johnson said. Still, he said, the speed at that ozone declined in Sept has slowed compared with 20 years ago.